I'm Jered Sutton, and I'm Managing Director at OpsStack, and I'm going to talk about transforming alerts into actions, generative AI as your DevOps Copilot. Now, when I say generative AI, probably a few of you, your eyes are rolling back in your heads. We've kind of been inundated with generative AI over the past 2 years. The little sparkles, they're all over just about every app. It's been crammed into every corner of every piece of software that could possibly have a need for it. And I think a good chunk of those cases are probably over-exuberant, maybe. But that doesn't mean, I think, that there's not some good use cases here. And I think especially in the case of DevOps, I think adding generative AI in some certain spots may actually help us accomplish our goals. So to start with, I'm going to define a few terms. So the first term I want to talk about is what generative AI is. So generative AI is an artificial intelligence system capable of generating new content, such as text, images, or code, by learning patterns from existing data. Some examples of this would be large language models like ChatGPT, Anthropic's Claude, generative adversarial models like StyleGAN, diffusion models such as DALL-E, Flux, Stable Diffusion, Midjourney, etc., and more. But today, I think the type of generative AI that's most applicable or is most ready able to be used are large language models. So what is a large language model? A large language model is a general purpose tool for statistically modeling token streams. It uses a transformer architecture and an attention mechanism to understand the text, the input text, and then an autoregressive token generation mechanism to spit output. That's a lot of words, but what it sort of translates to is we've managed to build a mechanism that can make a passable, like sort of a simulacrum of reasoning, right? It can do something that looks like reasoning. Whether it is reasoning or not, we can still use that particular element. It can perform tasks that would normally require a human to perform reasoning. The second term I want to talk about is Copilot. So when I say Copilot, you of course all immediately think about the wildly successful Microsoft product line and/or GitHub's code generation utility. But that's not the only way this term is used. It actually, prior to that, would most likely be associated with the airline industry. Copilot is a qualified pilot that supports the captain in operating the aircraft. So there's a few things I think that are interesting in that. The first is it's a qualified pilot. So a co-pilot isn't just a flight attendant. A co-pilot is not a mechanic. A co-pilot is a qualified pilot, so they're capable of flying the plane. They support the captain in that they don't fly the plane at the same time as the captain does. That wouldn't make a whole lot of sense if they were fighting over the yoke of the aircraft, although it might lead to some interesting results. But they support the captain. So the captain is flying the plane. The co-pilot supports the captain in flying the plane. Now, there are cases where the co-pilot may fly the plane, right? So if the captain gets up, if the pilot has to use the restroom, if the pilot has a heart attack, if the pilot is otherwise indisposed, then the co-pilot takes over. The next term I want to talk about is alert fatigue. So alert fatigue is, at least for the purpose of this talk, the desensitization to alerts due to their high volume, frequency, leading to slower response times and missed critical alerts. So I want to take a couple of quick polls. So the first poll is, show of hands, do you feel like you suffer from alert fatigue? Mm-hmm. I'm in the right place. This is good. Just had nightmares last night of nobody raising their hands, and I thought, we've solved DevOps. The second poll is, do you ever feel like you miss, or well, whether you feel like it or not, do you ever miss actionable alerts? potentially as the result of it. And don't worry, I'm not taking pictures. We're not sending these to your employers. Like, I know I've missed some critical alerts before. What happens when this occurs? What are the results of alert fatigue and when we miss critical alerts? Well, so one of the results of alert fatigue is that we lose team efficiency. So our team is not responding to alerts, right? We're missing things, so that decreases our efficiency. We have an increased risk of overlooking critical issues, which leads to outages, which leads to revenue, like revenue problems with our companies. We lose customers, we lose our jobs. Like bad things happen when we miss critical alerts, right? Now, conversely, nothing really happens when we miss an uncritical alert. Right? Nobody ever really complains about the flapping alert that we missed. Some obligatory statistics. According to Critical Start, 23 to 30% of alerts go uninvestigated. That's potentially alarming. Some of those are useless, of course, and some of them are critical. And some of them will become critical, right? The disk alert that's been pinging every night, but we don't realize that it went from alerting at 95% to 96% to 97%. An APA study found that up to 40% of productive time is lost in context switching. I don't know about you, but this feels particularly true. I'm sitting at my desk and something pops up and I go off to investigate it, and then I get back to my task of maybe even solving, I might even be doing an incident review for the last critical incident, and another alert comes up or somebody pings me. We can lose a tremendous amount of time switching back and forth because every time I come back, I have to reorient myself around whatever that complex system is. But that's okay. This is fine. Everything's fine. We have all of these great tools and observability mechanisms to see our systems. There's really no problem here, is there? Observability and monitoring love and all of these movements within DevOps to help us see what's going on in our systems have made some tremendous gains, and we've, life has gotten better as a result of these things. But something else that's happened is as our systems have gotten more and more complex, we are generating more and more data. Who's looking at this data, right? Like we have so much data from, you think about a Kubernetes cluster. There's data in just, your observability data is filling up disks because you have so much access to different bits of data. And it's great when there's an outage, you can go find these things and search for them. But who's looking at it otherwise? Generative AI. It will solve all of our problems, right? Like generative AI is the super person who will fix it all, right? Well, maybe not. But I do think there's some valid use cases here. So the first use case, question and answer. This is the one that everybody's probably familiar with. ChatGPT, right? We go in and hop in and we say, hey, just tell me what to do, right? There's an interesting tool along this line that we'll use in a minute called LLM. It's a library by Simon Willison. I think it's a really great tool for this particular case. I think that when we're dealing with Q&A and just asking the LLM questions, I think there's two things to kind of remember. One is it works best for questions that are easy to verify, for which the answer is easy to verify, but which the answer is also hard to find. So things like the tip of your tongue type stuff, or commands that you remember and you kind of know what it should look like, but you don't know exactly what it should look like. There's some really great, it can work really well here. Scripting, code generation, code understanding, tools like Cursor, GitHub Copilot, and I think somebody had a cool sort of array of different products and tools that are in this space. It can be used as a command line copilot. There's a tool called Clio, written by Darren Shepherd, if you're familiar with K3S. He wrote K3S, wrote this tool called Clio that you can interact, you can sit on your command line, you can interact with it, you can ask it questions, it can propose commands to run, and it can run those commands. It will always ask you, and it's sort of attempts to be a safe way to integrate generative AI on your command line. It can also, we can use generative AI to perform automated alert triage and enrichment. So we can use generative AI in sort of an agentic form to go out to our systems and collect data. So let's say an alert comes in, we can go collect the system metric data. We can go to like 5 or 6 different systems, pull that all together. And so before the alert ever arrives at the engineer's desk, we have lots of extra data and potentially some suggested remediation actions for the engineer to perform. And then finally, we can potentially use generative AI to just fix it. Automate incident resolution. So let's move beyond the bullet points and like kick the tires on a few of these things. I think that's probably large enough, but we'll bump it up just a hair. OK. So the first example I'd like to show is my application crashing. There we go. Demos. Oh, I see the problem. OK. First example, I'm going to use LLM to open up a quick chat prompt. So we're going to use the Claude 3.5 Sonnet, and we're going to ask it some basic questions. So we're going to say, how All right, so we're going to get some responses back. And in particular, we'll get one of my favorite responses back, the one that I'm always forgetting about, which is the one that uses dev TCP host port. So this is something I use a lot in my troubleshooting because I end up getting on systems and inevitably they don't have Netcat or Nmap or one of these other tools. And so I can never quite remember exactly how it goes. And I always end up forgetting to write it down. And so I can use an LLM now to help me remember tools and sort of like neat hacks like this that let me find out information that I need when I need it. And I already know, and it's easy to verify because I've seen it before. I know how this thing works. I just can't ever keep all of these bits inside of my head. All right. So the next thing we can use is we can use it to help us with scripting. So I have a basic shell script here that I'm going to be using for like a later part of my demo. But let's say I want to like see, how do I make it better, right? So I can use a tool like Cursor, and I can highlight it, and I can say, hey, you know what? Let's see, make this more idiomatic. Sure enough, I get some good suggestions here. So I get the set options at the top of my bash file to cause us to fail immediately. My directories have been moved into variables. This is a good practice. My variables have been quoted, another good practice. And then we've got this setup SSH command. This is actually great. This is the first time that this has popped up. This is actually a suggestion I might not want to accept, right? So I can see, I get some suggestions, some things that are elegant, some things that make things better. Oh, I see. That's setup SSH. It functionalized it. There we go. OK. So it's now functionalized my operation. So we can use we can use the help on scripting, right? This can be useful. We can also do things like we can Control backspace, Control. Here, we can also open up a Docker file potentially, and we can say so we can ask generative AI to optimize our Docker files for us. Now, and we'll cover this in sort of best practices later, I wouldn't recommend just sort of zero-shotting it with like just optimize my stuff. But I want to use this as an illustration to show just how good the results can be even when you're just asking an LLM to fix the problem. They're trained on an enormous amount of code, and it turns out that code, like English or Spanish or German, is another language. And it's a particularly structured one. So the patterns and the statistical patterns that emerge, they're stronger patterns. And so as a result, LLMs actually do a pretty good job at generating code. So we can ask it, and it will give us some good suggestions around optimizing our Docker file just out of the gate. Moreover, when we do it this way, we can also have it explain to us what it did. So we can go check the answer, right? So we can say, oh, hey, you suggested I do this. This is why you suggested I do this. Let me go look up the documentation and see if that's actually what it is. Sometimes we learn something new. I find this to be a particularly good approach because I've learned things about Python. I've learned things about Docker files. I think I learned in one of the iterations of this, I learned something new about Docker files that I hadn't previously known. All right, and then our third example is as a command line Copilot. So I can ask Clio, the command line Copilot, let's see. Say what EC2 instances are running. So it'll ask me, it'll say it wants to use the AWS CLI. I'll tell it yes. And then it will tell me what it wants to run. And it will prompt me to say whether I want to run it or not. So this gives me an opportunity to review the command and see if it's actually doing something that I want it to do. I can authorize it and say, go ahead. And it'll return to me using my AWS credentials that are on my box. It will, the response back from the generative AI will pass through Clio, and it will suggest running this command. Clio will handle asking for my approval and then subsequently running that command and retrieving the results and telling me that I have one instance running. And I can ask it then questions such as, what is the public IP? It'll give me a command, and it will deliver me the public IP of my instance. The last example that I want to show, we'll do we're going to have a setup here. So we're going to take an EC2 instance. We're going to make something go wrong. So something will go wrong with the instance. It then sends its metrics to CloudWatch. CloudWatch has an alarm configured to look for something wrong. When that something wrong happens, it will generate an alert. That alert will go to an Amazon event bus. No, I don't work for Amazon. It just was easy enough to kind of put it all inside here. That event bus will trigger a rule that has an action that will start an ECS container. That ECS container will start up, and that instance will run a piece of software called GPT script. It's kind of a wrapper around a prompt that will take the alert alert context that it gets from CloudWatch. It will have some instructions to check on the instance itself and collect data. It will then query OpenAI, and it'll attempt to resolve the incident. So let's see how well it does. So we're going to start by stressing our CPU out. And while this is going on, we'll walk through this a little bit. So what we've done is inside of this container, we have a Docker file, which we've seen before because we were just looking at it. And this Docker file, all it does is goes and grabs GPT script, it extracts it, moves over my tool.gpt, an entry point, and then it sets the entry point to entry point.sh. That entry point, in turn, sets up the SSH key, pulls it from an environment variable, which we present to the container at runtime, sets up that access, and then runs GPT script using the tool.gpt. And that tool.gpt has plain English instructions that say, this is the prompt. The prompt is that you've received an alarm. You're going to get alarm name and an instance ID. Take the following steps. Try to get the IP of the instances. Determine the IP to SSH into by checking the port. SSH into the instance using the IP, and try to determine the cause of the alarm name. Trying up to 5 commands. Attempt to resolve the issue, and then output the diagnosis if you find it. To do that, we give it access to a set of tools. One of them is built in, sys.getEnv, which gets environment variables. And then we give it access to these 3 commands: get instance IP, run instance command, and check port. These are then defined further down in the file by just small shell snippets. And we can define their arguments and what tools they in turn get access to, like sys.exec. And then from there, we should see an alarm. And we do. So we see that we now have our instance in alarm. If we flip back over to our text edit, we should see be able to see this spin up. There we go. We see our instance spinning up as of 6 seconds ago. So now it's checking the instance itself to see what's wrong. And we'll see if the demo gods smile upon me today. And there we go. Our stress instance was terminated. Our machine should be returning back to normal now. When we go and look at what this task was doing, we can take a look at the logs, which are going to be very tiny. So we'll try to make that bigger. And we can see that the GPT script started up. It ran the prompt. It determined that the diagnosis was that the alert was high CPU that was caused by a process named stress, and it took the resolution action of killing the process. So great, incident solved. Our alarm should now clear. Eventually. Man, metrics never run as fast as you want them to. All right. We'll come back to that in just a moment. It's artificial intelligence, right? What's there to worry about? Well, this contrived example is sort of intended to push on the premise of what are the possibilities, but there are also some problems. Hallucinations, right? This is probably the most common downfall to generative AI that people bring up. Sometimes it just says something that's incorrect. The generative AI will typically, or LLMs in particular, they will confidently answer you every time you ask them. And that confident answer may or may not actually be accurate. You have the potential problem of data leakage. So we have our container running, it goes out and SSHs into this instance. Whatever comes back, that's getting sent up to OpenAI, right, to our inference engine. We have commands that are being run on the instance, right? So what if that command is curling or moving files around or potentially leaking data in that way? So there's all kinds of different ways that this application can, or that generative AI can potentially leak data. We have data destruction. What if it ran the wrong command, right? What if it decided to RM my file system instead of killing the process? Or quite frankly, what if it kills the process and the process is not safe to kill? And then there's just the small problem of killer robots, right? Which seems like funny, except that that's actually not too far off. So is it possible for us to get some of the benefits of generative AI while minimizing the downsides? I think the answer is yes. How do we do that? Start small, right? Don't start in production, right, obviously. But start with small use cases. Open up ChatGPT. Use simulated context, right? You can do most of the things that these generative AI tools do, or that the LLM tools do, by just faking the context. Like, tell it what it sees. Try your prompt. See if you can get consistent results, right? Start small with something like well-known services that you're trying to get it to interact with. Ask it questions. You can start small by using just something like Q&A with the LLM tool. You don't have to jump straight to doing something like automated incident resolution. But start small. Work out the edges. Remember that this is a non-deterministic computer. This is not the computers that we're used to working with. These LLMs, they work more like a human than they do a microchip. When you're prompting LLMs, try to be simple, specific, and short. Keep the request simple, make it specific, and keep it short. Don't write a long novel and then ask it to answer the question. Also, don't make it overly broad. Don't do what I did, which is to say, optimize my file. Choose the right tools and models. So I've given some examples of what I think are particularly good tools. When you're looking at model choices, what I would suggest as you're starting small is try to stick to the flagship models and the frontier models initially, right? Validate your use case. See if the best of the current model set can even do the kind of reasoning that you want to do. Once you've validated your use case and sort of figured out, hey, this could actually work, then start stepping back to the sort of the dumber models and look at the other and things that are either cheaper for inference or have better data security guarantees. Because if it's not possible now, you're certainly not going to get it with a smaller model. Keep it secret, right? Don't expose extra data to the models at inference time. So some of the ways you can do this are to use tools like GPT script, where you're providing, like, the model never sees the SSH key that it's using to SSH into the host, right? That SSH key won't be exposed to OpenAI because it's underneath the hood, right? We're just giving the access to the container. So like in the case of the ECS container, the other thing that it can do is look up the instance IP. I didn't put an access key in there. The actual container the container role is allocated access, right? So watch your secrets. And honestly, to some degree, this is just general good practice, right? Don't expose secrets, right? Don't check in your secrets into your source control. Put the secrets where they go. Use audit logs. So in the case of what we just showed, we have our logs in CloudWatch. It tells us what it did. But that's not the only place, right? We need to also have audit logging turned on our machine. Our EC2 instance should have audit logging turned on so that we know what actions were taken. Those get sent up to and use all of the existing sort of things that we already know. Use centralized logging. Have these things log back where we can correlate and say, oh, hey, we see the CloudWatch alarm, which then triggered the event hub rule, which triggered our ECS instance. We see the container startup. We see the actions that the container took. And, oh, by the way, we also see the actions that were taken on the EC2 instance. So if we have to trace back, we can do that. And then add constraints. So in the example, I let it run any command on the host. But you wouldn't let a junior admin do that. You wouldn't let a level 1 NOC admin do that, right? We constrain users. We say, oh, hey, level 1 NOC admin, you get access to restart services. Right? You get access to a constrained set of commands. You can do that both in the GPT script file by constraining the tools that it's allocated, but you can also do that with our existing RBAC tools inside of operating systems, right? You can allocate the user privilege to sudo certain commands and not others. It's also a good idea to use retrieval augmented generation. So one of the things that can make large language models more effective at their tasks is by providing them additional context. We have runbooks. I hope you have runbooks. You should have runbooks. We have runbooks. You can use those runbooks and have the LLM query them using a RAG system so that your LLM now not only does it have access to this, the information from the system itself, but it also knows, oh, here are the services that are running, and here's the proper way to restart the service. But I'd be remiss if I didn't mention the goal. What's the goal here? Because it's one thing to see a cool new tool and try to implement it, but if we're doing DevOps, right, we need to keep the goal in mind. What's the goal of our organization? What are we trying to achieve? In the books The Phoenix Project and The Goal, they introduce the metaphor of the factory, right? We have raw supplies come in one side, finished goods come out the other side. And understanding what it is that we produce is important because it allows us to go then into the factory floor and identify what the constraint is that governs how many goods and services we have coming out the other side. And it's notable that there's only ever really one constraint at a time. And as we go inside the factory floor and we find that constraint, then we can use the 5 ways to resolve the constraint, right? So we can identify the constraint. So let's say it's a die press. We can exploit the constraint by keeping the die press running 24/7. We want to keep, like, the die press is the thing that governs how fast things come out of our system. We can exploit it, keep it always running. We can subordinate everything to the constraint, right? Nothing gets done in the factory that isn't on its way through the die press, so we limit our work in progress. Then we can elevate the constraint. Maybe there's a die press in the corner. We can bring that online. We can add an additional die press to the system. And we do that until the constraint is no longer the constraint. So I mention this because if human resources, if reasoning capacity is not your constraint, don't bother with anything of what I've just said about generative AI, right? If your constraint is system scalability, focus on that. Find the constraint in your system and exploit that and work on that before you wander off into new tool territory. So you might be thinking, that AutoSA, isn't that Ultron? Right? Aren't we just letting AI sort of have its reign? What about Iron Man versus Ultron? So there's a paper written by Tom Limoncelli that explores the notion that automation should be like Iron Man in suit components, right? Automation should be about empowering the human to do more and better things, not like Ultron, the robot that tried to kill everybody. But it was fully autonomous. And I think this is a valid concern, especially when we look at sort of the pushy edge cases like the AutoSA example. But I think it's also worth noting that in the Iron Man suit example, right, you have small servos, climate control, attitude control. You have a number of autonomic systems that enable Iron Man to do awesome things, but he's not thinking about how to fire a servo in his heel. Our bodies have autonomic systems. They're systems that perform actions and take and correct. I don't think about how many muscles I'm firing to extend my arm. I think about extending my arm. And so I think as we're looking at where do we apply generative AI, we will start to bump up against these notions of is it Iron Man or is it Ultron? And I think it's worth considering where those lines are. And I'm definitely on the line of let's build the Iron Man suit, not Ultron, by the way. I'd be it's almost obligatory. What are the key performance metrics? How do we measure success? How do we know if we've been successful at deploying generative AI? So 2 possible metrics that we could use. How many alerts had the incorrect action taken? And what is the percentage of alerts that ended up having to be escalated to a human? I think what's worth noting here is that both of these metrics could also be used with humans, right? So how many times did a human take an incorrect action? How many times did the level 1 resource get escalated to the level 2? And I think this is kind of a recurring pattern where we see generative AI a lot of the same tools and a lot of the same structures and supports that we use for humans can be used in generative AI applications because they sort of behave a little bit more like a human than a microchip. So as we look forward, what are some things we might see in the future? So I think in the next 6 to 12 months, we could start to see, or we'll start to see, multi-agent systems. So the GPT script example that I showed you, this is kind of a single agent. It's a very simple single agent. But I think we'll start to see multiple agents talking to each other, interacting to solve problems. Now, I don't know if I'm advocating for this in a DevOps context, but we're going to see it. We're going to be supporting these systems whether we use them or not. Memory, short-term and long-term. So right now, there are a few projects out there that are sort of endeavoring to give an LLM sort of runtime memory. So think of it like extended context, the ability to remember things over time. So, oh, hey, you restarted that service last time, don't do that again. Remember this the next time. So persistent memory. I think that adds some really interesting promise for not having to fine-tune or train new models, but actually having them be able to learn and incorporate lessons over time. Voice mode. OpenAI just introduced voice mode 2 weeks ago. Advanced voice mode for everybody. I think there's an interesting use case in being able to have your systems talk to you and you be able to talk back. I don't think voice is the end-all be-all from an interface perspective, but I think that it adds an additional dimension when I can have my systems call out to me and say, hey, I've got a problem, and I can respond without having to sort of break the context of what I'm doing, like potentially reduce the context shifting. And then the last would be, and I think this is probably the furthest out, thinking of an LLM, a large language model, as being something more akin to an operating system kernel, and natural language as being the programming language for it. This is the general premise or the gist of what Darren Shepherd's kind of getting at with the GPT script. And I think there's some interesting promise there where we start to, and this wouldn't be for your desktop OS. So I know there's a popular movie where this kind of happens, but I think if we think about it in terms of OSs outside of the desktop OS, I think we might start to look at LLMs as being the kernel for a new type of operating system. And with that brings me to a close. Here's a set of references if you want to have a look at that, but thank you very much for your time.